Dear NEET aspirant, now we go to the GOC part 2 video. This video is fully covered in the organic compounds. It's a classification. In generally, the organic compound that is classified in two types. One is aliphatic compound, another one is organic compounds. Okay. So now see these two one by one in detail manner. First of all, that's aliphatic compounds. This aliphatic compound is classified one as acyclic compound, and the second category is cyclic compound. Okay, so these two it possessed the carbon and hydrogen only. Then third type, that is a heterocyclic heterocyclic compound. Okay, so this heterocyclic compound is very rare, especially for that aliphatic manner. Okay, first of all, the aliphatic compound in the case of alicyclic or acyclic, that is a acyclic compound. This acyclic compound not in the cyclic, or you say there is a chain like structure. Okay, so here one has a alkane, and second category that is for alkene, and third category that's for alkyne. Okay, so like that the three kind of the compounds are presented in the acyclic as well as the cyclic. Okay, in generally the alkane, first case, that's a alkane. This alkane is a general formula CnH2n plus 2. It's for the alkane, it's a general formula. If you assume n is equal to 1, we can substitute C1H2 into 1 plus 2. So that is equal to for CH4. Yes, it's for that methane. For this alkane, the suffix are ane. Okay, so similar like that, any hydrocarbon that is under the category of alkane category. Okay, then if you assume there is a n is equal to 2, there is a n is equal to 2, here C2H2 into 2 plus 2, that is equal to C2H6, that is for ethane. So methane, ethane, next propane, butane, like that, that is studied. The next as a alkene. Okay, there is a alkene. This alkene general formula CnH2n. If you assume n is equal to 2, okay, that's a C2H2 into 2, that is equal to C2H4. This alkene, it possesses the carbon-carbon double bond. Here the CH2 double bond CH2. Whenever the carbon-carbon multiple bond are presented, that is for unsaturated compound. Okay, because the carbon is a valency as a 4, but in the case of 4 is satisfied, here 3 sigma bond, 1 pi bond for each 2 carbon. Okay, so this is a ethene. For this name, the suffix as a ene. So whenever the acyclic compound containing carbon-carbon double bond, its a name is a came at suffix in the e like that. Okay, and similarly there is a third type such as alkyne. Okay, it's a general formula CnH2n minus 2. Okay, now n is equal to 2. If you assume the formula, that is a C2H2 into 2 minus 2. Okay, so we can get that there is a C2H2. Okay, so this is a HC triple bond CH. So this for ethine. Okay, so whenever the compound it possesses a carbon-carbon multiple bond, especially the carbon-carbon triple bond, that is under the category of ethine category. Okay, done. So before this, the ethine carbon is a sp hybridization, and the previous case of alkyne carbon, that is a sp2 hybridization, and the last previous case of alkane, that carbon is a sp3 hybridization. Okay, the next there is a B type for cyclic compound. Okay, cyclic compound. Here also as a alkane, alkyne, like that the compound are presented, but in the case of the cyclic basic skeleton. For example, this is a 1 2 3 4 5 6 carbon, so that is called each carbon as a only sigma bond are presented, so there is saturated 6-membered cyclic structure of cyclohexane, cyclohexane. Okay, and similarly this is a saturated 4 member ring, so there is a cyclobutane. Okay, okay, so this is a alkane category, alkane category. And similarly alkene category, the same compound, but instead of ring only one double bond, that is a cyclohexene, cyclohexene. Okay, so this is the name. And this is a cyclobutene, cyclobutene. The many of the student possessed like this doubt. Actually here only one double bond is there, and also it's a possible here double bond or here double bond. Yes, that is also possible. If any compound possessor like that, we can dictating the double bond. Okay, the position of double bond. For example, here is double bond and here is double bond. We can go to numbering 1 2 3 4, where that double bond are presented. See this first carbon and this the third carbon. So there is a 1 comma 3, sorry, yes, 1 comma 3 cyclohexa diene. Okay, 1 comma 3 cyclohexa diene for this name. Okay, so this is a cyclic compound of alkene. And there is a alkyne. We have a doubt if the minimum of cyclic compound ring, there is a 3 carbon. Okay, so in the case of, see the cyclic alkyne molecule, the cycle minimum number of carbon has a 3 carbon. Okay, the cyclic alkyne compound, this, if you assume this is a cyclopropane, inside of one double bond, that cyclopropene, this is a triple bond. Okay, 1 2 3 among these 2 carbon. So this compound is not exist, because practically think about this carbon of hybridization sp, and this carbon also has a sp hybridization. Such a kind of sp hybridization, that's a linear geometry. Okay, but in this carbon sp hybridization, so this not in the linear geometry, this is not in the linear geometry. So according to sp hybridization, there is must be the linear geometry. For that reason, it's not in the linear geometry, so it's not exist. These molecules are highly unstable. So when the cycloalkyne are exist means, see the CH2 as a n times, there is a carbon carbon triple bond carbon. So they like that. The higher number of polyenes that is exist for alkyne. Okay, otherwise the lesser number of carbon containing alkyne is practically is not exist. Okay. Okay, then next the heterocyclic. Heterocyclic, mostly that's a very rare this topic for aliphatic. It's a aliphatic. Okay, for example, the oxirane or epoxide and the this molecule. Okay, the tetrahydropyrrole and the tetrahydrofuran and the tetrahydrothiophene, tetrahydroprudine, etc. Those are the heterocyclic aliphatic compounds. Hetero means in the cyclic ring is covered one of the hetero atom. Okay, and the homocyclic means all the cyclic covered atoms only for carbon atoms. Okay, the next we go to the organic in the classification of the aromatic. Okay, aromatic compounds. These aromatic compounds, there is first category, that is a benzenoid aromatic, benzenoid aromatic. Okay, then second category, non-benzenoid aromatic, non-benzenoid aromatic. Okay, so the benzenoid means the benzene related compounds, all there is a benzenoid compound. For example, this benzene and naphthalene, anthracene, phenanthrene, those are the benzenoid aromatic compound. In the non-benzenoid aromatic compound, there is two types. One is ions, another one is a heterocyclic. Okay, heterocyclic neutral compound. So these ions, see the cyclopropenium cation, cyclopentadienyl anion. So here is a minus, the cyclopentadienyl anion, and the tropylium carbocation, double bond, and double bond. Here is a positive. It's a tropylium carbocation. Those are the ions. Even that is a aromatic compound. And heterocyclic classified in two types. One is actually three types. One is a 5-membered ring. Okay, 5-membered ring, simply the furan, thiophene, pyrrole. Those are the example of the 5-membered ring. So there is a thiophene, it's a furon, it's a thiophene, and this 6-membered ring, 6-membered ring. This example for the pyridine. Okay, this is a pyridine and combined of two 6-membered ring. For example, quinoline, isoquinoline. Those are the example. And here 5-membered and 6-membered is combined. Indole, that is example as a indole. For example, one of the 6-membered and here is a 5-membered. This for the indole. This 5-membered, this is a 6-membered. That is a combined 5-membered and 6-membered. That's called as a indole molecule. Okay. So last one thing, whenever a molecule, whether they have aromatic, anti-aromatic, or non-aromatic, such a conditions. First of all, there is a aromatic. Here is a anti-aromatic, and the last one is a non-aromatic. So these three kind of relation only the molecules all is possessed. Aromatic molecules must be the cyclic, and second category molecule as a must be planar geometry, and third one is a extension conjugation. Okay, so we will study at the future classes what is a conjugation, how it's exist in the molecule like that. Simply saying the double bond are alternatively possessed, or the conjugated means there is a electrons more easily to resonating. Okay, the last one, that is obeying the 4n plus 2 pi electrons. Okay, so this rule for Haeckel rule, and that anti-aromatic, the first three points or first three rules are must, and last one, there is a 4n pi electrons is obeyed. Last non-aromatic, these three any one violation. Okay, there is a any one changes or violation, that is compound or non-aromatic. For example, the benzene, the all kind of molecules. Okay, benzene and cyclobutadiene, and that is a this compound. Okay, that is cyclohexane. Here this is a cyclic compound. Okay, and this all carbon as a sp2 hybridization. So it is a trigonal planar as a geometry. So this planarity is came, and this double bond is resonating here, and this resonating. So the ring delocalization is occurred. Okay, so that's why that is a extinction of conjugation. It's a possible. So cyclic, planar, extinction of conjugation, and that pi electrons here, 2 4 6 pi electrons is there. So here n value as a 1 means 1 into 4, 4 plus 2, 6. Yes, that is obeying the 4n plus 2 rule. That is this compound is aromatic. And this second category, here the cyclic, and the all carbon or sp2 hybridization, that is a planar. This double bond separated here, this bond separated. So there's a extinction of conjugation also is possible. But in the case of this obey the 4 and pi electrons, because the pi electrons as a 4, if you assume n is equal to 0, the whole term becomes 0. So in the next category, n as a consider as a 1, the will become to the 4. N is equal to 1, that's a 4. Here also 4 pi electrons, here also will come to the 4. So this is anti-aromatic. In this case, the last one, this molecule as a cyclic, but not in the planar, because all carbon has a sp3 hybridization, that's a tetrahedral geometry. So whenever the tetrahedral means the any two bond or the on the plane, these two bond on the plane, and the remaining two bond or one is above the plane and another one is below the plane, that is two bond are off the plane. Okay, so this carbon is a sp3 hybridization. So similar like that, this molecule all carbon are the sp3 hybridization. For that reason, here planarity is affected. So the any one rule is violation, that molecules came under the category of non-aromatic. Okay, so these are all most essential and fundamental of the organic chemistry. I think you are well clear after seeing this video. If you want more clarity or any doubt, you can comment in this video. I will clarify you. Okay, thank you to all. Thank you very much. If you like this video, you can subscribe and like and share your friends. Okay, thank you.